Our job at Hurco is to make, usable and useful technology.
Hurco makes 4 different series of machines. We make 2 styles of trunnion machine. We have our standard A-axis trunnion that rotates around the X, and then we have a series where that's rotated 90 degrees, rotates around the Y. We have 2 different styles of swivel head machine where the head swivels 90 degrees both directions, but then you can either get a C-axis table that's mounted flush with the machine table, or add on an A-axis tilting table that would fit whatever size work that you have. And then we also have a DCX version, which is a very large 3.2 meter bridge style machine with a 5-axis head.
The things that make Hurco machines special is the amount of engineering that we put into it. We take a lot of pride in the way we build them. We scrape the bearing blocks, we scrape the mating surfaces, we check with optical lasers to make sure everything is aligned properly, and we have the accuracy and repeatability that we need in the product. Probably the most important feature of our machine is our control. We pride ourselves at Hurco, the design and manufacture of the control, both the software, the hardware, the ability for most anyone to come in front of the machine and be able to program it quickly and easily.
We came up with a new program type called the Universal Program Type. The customer just programs the part. He uses a feature we call Transform Plane. He just programs in 3-axis and transforms that feature to different orientations and locations on the part. And so it's really mostly 3-axis programming, and they're able to go from multiple setups in 3-axis, where they would fixture the part differently between the different sides, and just do that in software.
When I get a job in my shop, I can use the Hurco to do whatever makes the most sense for me. I can do conversational programming if it's simple 2D or 2.5D work. I can do G-code programming if it is a very intricate 5-axis or simultaneous may be necessary, for example. Or with Hurco, I can blend those 2 together.
We also design and manufacture our own spindles. We take pride in the selection and the design and build of key components that go into our machines.
Ultimotion is, you got to think of it as like the engine of the control system that handles the physics of the machine tool, make sure you've got very smooth motion, very efficient and fast motion, and it generates the ultimate, at the end of the day, the accuracy of your part.
I wholeheartedly believe that every shop has a place for a Hurco. If we're not looking for the 1.5-second tool changes, the 2G acceleration, some of the very specific things that might cause them to look at machines that cost 3 and 4 times that of a Hurco, there's no reason that they shouldn't consider Hurco.
That the Hurco has the power to do everything you need, whether it's NC or conversational, has that flexibility, but it's also the simplest 5-axis control on the market today. It's really easy to learn, really easy to use, and when you put all that together as a package, there's nothing that comes through your shop door you shouldn't be able to cut with this thing.
Hello, welcome everyone, and welcome to Transforming Your CNC Machine Shop webinar held by Hurco Companies Incorporated. It is my pleasure to welcome you today and introduce our expert guests. First, Dr. Paul J. Gray is the Vice President of R&D and Product Development. Our second speaker will be Mr. Lee Y. Ip, the General Manager of Hurco. This webinar is focused on how to combat competitive obsolescence and stay relevant in this new norm. This webinar is well suited for CNC machine shop owners, factory managers, senior machinists, and any company that is interested in CNC machines, in upgrading their production line or machine shop. Today, we will learn the following. Firstly, the power of 5X machining, and then job shop automation made simple. Our agenda will look as follows. Firstly, with the power of 5-axis machining, we will hear from Mr. Lee Y. Ip, the General Manager of Hurco, and then with job shop automation made simple from Dr. Paul J. Gray, the Vice President of R&D and Product Development. After that, we will have an open forum for you to ask all and any questions that will come to your mind, to use this time with our experts. After that, we will have a lucky draw. All of you will be entitled to win a prize, one of 4 sets of Hurco limited edition prizes. So there's definitely something to wait for. And after that, we'll have the closing remarks. So let me introduce our experts in a little bit more details. Mr. Lee is a General Manager of Southeast Asia Hurco for the 9 years. He is responsible for the overall sales and channel development of Hurco machine tools and control technology. And he was the leading person in establishment of Hurco China and Hurco India entities. Dr. Gray is the Vice President for Research and Development and Product Development for Hurco companies. He has 24 years of experience in CNC manufacturing and related technologies, including 5-axis machining, and he holds 8 patents. His focus is on automation, product integration, and interfaces. So certainly a very knowledgeable person. Now, before we start the presentations, I would like to conduct a quick tutorial for you how to utilize our platform to its full extent. Firstly, on the right bottom corner, you have the chat box where you can write any messages. And also, if you select the question mark, you can ask the questions for the Q&A open forum later. Also, any sentence that will be ended with a question mark will be marked as a question, so our experts will be able to find it more easily and answer to you during the open forum. Also, for everybody who would like to ask the questions or see the chat messages in their own language, on the right side, there's a gearbox icon. That's the option setting. If you select it and then go all the way to the bottom, you can choose the language for the automating translation of the chat. You can choose Vietnamese, you can choose Bahasa, or any other language that you feel comfortable with. And now, without further ado, I would like to give the microphone to our first expert speaker, Mr. Y. Lee.
Thank you, team. Good morning, everyone, and welcome to our webinar. My name is Lee Y. Yip, and I'm the General Manager for Hurco Southeast Asia. I'll kickstart today's program by introducing the power of 5-axis machining and why you should consider it as the first step towards business transformation. I would like to start my presentation for today using a customer's quote. I quote, "You just position and cut. It makes every operation just one operation. If you're not doing this, you're going to get left behind." This quote effectively summarizes our objective for today. It's about staying relevant, staying competitive so that you're not going to get left behind. So you may ask, why 5-axis? What are the challenges today that's driving the adoption for this technology among machine shops? Here are the usual suspects of the problems that we see day to day. Batch sizes are getting smaller, delivery times are getting shorter, lead times can also be susceptible to change. Shops are seeing an increased demand of high-mix, low-volume parts as opposed to mass production or batch production parts. In order to keep up, they're being forced to look for more efficient ways to produce this part in order to stay competitive. Customers, in addition, are getting more demanding. It's typical that they will throw in a last-minute order and expect the machine shop to be able to turn around the part within a short time frame. Because orders are being placed later and delivery times are sooner, jobs must find technology that allows them flexibility. So what are the machine configurations that's available for 5-axis machine? 5-axis is defined as simply 3 linear axes, X, Y, Z, plus a rotating and a tilting axis. You will likely be familiar with a trunnion machine setup or a cradle table setup, in this case, AC on the left and BC on the right. There's also the swivel head with the rotary table setup. As you can see, BC on the left, AB on the right. For larger machining centers such as dual column machines or gantry type machine, you will find the articulating head or the universal head. And last but not least, the add-on tables, add-on trunnion tables are highly popular as an add-on feature to 3-axis machine to provide the additional tilting and rotary axis. So what are some of the practical benefits of 5-axis machining center, and how can 5-axis technology make your business more competitive and profitable? In general, 5-axis allows you to reduce the overall production time frame. Moving from a traditional 3-axis to a 5-axis machine would help to reduce your overall cycle time through reduction of setup time. It also minimizes the need to build fixtures for multiple site jobs. This means that you can offer a more competitive pricing, win and take on more orders. The rotary and tilting axis on a 5-axis machine helps you maneuver and orientate the part to the specific plane and angle for machining in a single setup. This means that unlike a 3-axis machine, on the 3-axis machine, you will need to manually flip the part between operations, which may result in inaccuracies or inconsistency in the machining process. Besides spending more time, there's also a higher risk of error and scrap. Let's look at an example of a traditional 3-axis versus a 5-axis setup. The top picture shows a multiple site part that is machined using multiple operations. The bottom has the same part machined on a 5-axis machine with 2 setups. As we review the total production time, the setup time, loading time, and cycle time, you will see substantial saving in both the setup time and cycle time. In a traditional setup, a machinist will have to spend time and resources to build fixtures in order to cut a complex angle, while for a 5-axis machine, you just position the part. Contrary to the belief that most companies do not work on complicated 5-axis parts, a 5-axis machine in fact helps to inject creativity and capability to a company. Designs that are deemed too creative and not realistic or not machinable are now possible with 5-axis technology. Companies will adopt 5-axis machining can now increase the type of products and services they can offer to their customer. Let me share with you a case study of our customer in the old school business of making car wheels or rims. Most car wheels, as you know, are mass-produced and milled or cut using a 3-axis machine. This limits the design of the wheel to its face or necessitate the use of 2-piece wheels for the more fanciful designs. Our customer is in the business of manufacturing bespoke or customized forged wheels that is being milled or cut out using a 5-axis machine. The company is able to incorporate aggressive and futuristic designs such as 5-axis C channeling, side sculpting, and radius I-beam cut, which is not possible with a traditional 3-axis setup. As a result, the wheels are targeted at the higher end market for performance and luxury cars. If you look at the picture on the left, you will see the side sculpting, undercut, and through-hole spoke design. Let me share with you now a video of the actual machining of the wheel using a 5-axis simultaneous cut. You will see the tilting B-axis and the rotating C-axis moving simultaneously to achieve the C channeling undercut on this wheel. The simultaneous 5-axis movement also allows the cutting tool to be able to reach the sides of the spokes and ensure that there's a good surface finish quality. As for the day-to-day machining, 5-axis allow you to utilize shorter cutting tools to eliminate chatter or vibration caused by an overhanging tool. For example, when machining a cavity. By tilting the part slightly, you are able to bring the tool closer to the surface of the part and avoid the use of elongated tool. Let's look at this illustration where a 3-axis machine is used to machine a deep core or in a cavity mold machining. On a 3-axis setting, you will need to use an elongated tool or a longer projection tool like this in order to avoid the top surface of the part. When you apply 5-axis machining to the same part itself, you'll realize that the tilting and rotating axis allows you to bring the part closer to the actual tool while avoiding any possible interference from the cutting tool. This results in a shorter tool, a shorter and more rigid tool, allowing you to cut at a faster feed rate and also achieve a deeper depth of cut, thereby improving surface finish quality while reducing cycle time. There are generally 2 ways to talk about 5-axis. It's interesting that whenever an end user comes to me to inquire about 5-axis machine, typically they will share with me that, hey, I'm looking for a 5-axis machine. Do you have a 3+2 axis? Or they may pose a question to me that, oh, are your machines 3+2 or simultaneous 5-axis? So what are the real differences between these two approaches, 3+2 or simultaneous? Let's compare them. Let's start with simultaneous 5-axis. Simultaneous 5-axis machining is always impressive to watch. In fact, machine tool builders and CAD/CAM suppliers typically like to show off what we have using a simultaneous machining toolpath. There are, of course, apparent benefits besides looking sexy and impressive. In general, simultaneous 5-axis machining often produce a better surface finish and delivers an increased tool life, as it allows the tool to be orientated during the cut. This helps to make sure or ensure that your ball nose cutter is always cutting on its flute rather than dragging at the bottom center. Most importantly, as you can see from the demo video that I've shown you on the simultaneous wheel cutting, simultaneous 5-axis allows cutting tool to reach into areas that aren't possible in the static presentation of a work. workpiece. If the workpiece is static, it causes interference, and this is precisely the reason why simultaneous cuts are used for the case of the C channeling of the wheel demo, or in the case of a steep impeller, On the other hand, 3+2 machining or multiple site machining is very easy to program. You can simply shift the part datum and apply a transform plane to move from one surface to another. This can be easily programmed using conversational programming if you do not have the relevant experience on the CAM software. The linear axis in general have higher cutting feed rate than the rotary or tilting axis. As such, utilizing the linear axis for cutting will achieve faster cycle time and allow you to adopt cutting strategies like trochlear milling to reduce cycle time further. Since the rotary and tilting axes are static instead of moving, concerns of collision, tool collision, or interferences are reduced. I'm sure by now you'll agree with me that 5-axis machining does inject direct benefits to your business by reducing production time, improving part tolerances, part surface quality, and allow you to win potentially allow you to win more orders. But how do we address the issue that you can only hold one part at a time? Most first-time 5-axis users will adopt a self-centering vise, a dovetail fixture, or even use a 3-jaw scroll chuck as their first fixturing solution. However, if you inject a bit of creativity, you can apply your fixturing design skills or invest in a modular clamping solution that allows you to clamp multiple workpieces depending on your part geometry. In this video, you can see that we have utilized a anchored modular fixture to clamp up to 4 parts at one go. Even while adopting a simultaneous toolpath, there is no risk of the tool actually hitting the other 3 parts if it's properly being set up. Here are further examples of modular fixtures with the familiar zero clamping system or a palletized system that allows the use of a single reference point. You can also mount these multiple site fixtures on a palletized system in an auto loader. The key about clamping multiple parts lies in creativity. Look at the part and explore how the material can be clamped to provide more flexibility for your cutting tool to approach. You can organize to have multiple pieces of the same program to a table, fixture to a table, or use an OP1 and OP2 approach. Traditional work holding theory that a tool cannot reach the inside face of the part due to interference issue can be simply avoided by tilting the part at 45 degrees. This will allow you to access all 5 sides of all parts. Should you now decide on taking the plunge by investing on a 5-axis machine after this webinar, I've prepared a pre-purchase checklist for your kind consideration. For a 3-axis machine, buyers would generally pick the largest machine they can afford and their workshop will be able to fit in. Well, the rationale is that you can always machine a small part using a large machine, but not the other way around. You may wish to know that bigger is not necessarily better for the case of 5-axis machine. Instead of looking at the machine travel or table size, you should consider the individual part size or the overall part family. The trunnion table diameter, while choosing the trunnion table diameter, you should look into the part size in terms of which machine best suits most of the parts without being too large or too small. In this illustration, you will see that in this illustration where you try to machine a small part on a large diameter trunnion table, in such a case, you would generally have to use a longer tool holder, or you may even have to stack up the part in order to avoid any possible interference from the spindle head towards the side of the trunnion table. A longer tool, in reality, may cause vibration issues and affect the overall service finish. Next, you would also want to review the overall part setup or the fixture design. Besides just looking at the raw material size, you should account for the total height of the fixture when measuring the height of table. In this next illustration, you will see that while applying the modular fixturing, this makes setup easy and makes it flexible for fixturing various materials. However, this would certainly eat into your overall travels. When the part is positioned at the zero position, when the part is at a zero position rather, you will find plenty of Z-axis clearance at 0 degree. However, when you start to tilt your A-axis towards 45 degrees, you will find that your Y-axis is kind of limited now. And when you tilt it further to 90 degrees, there may be occasions where if you have a limited Y travel, you will not be able to reach the end of the part, therefore insufficient travel. Last but not least, the end is often being forgotten by most buyers, would be the length of your necessary tooling that you'll be using for your applications. Longer tool lengths generally eat into your travels. So do remember the tooling that will be required to machine the part so that you can account for the overall tool length when choosing the right machine and for your application. In this illustration, you will see that if you're using a longer tool like a gun drill or a long boring bar, you will definitely need a longer x-axis travel in order to open up the space for the tool retract or the cutting operations. So let me recap. When looking at investing on a 5-axis machine, there are 3 points that you need to look at. First of all, the size of the trunnion. It doesn't mean that the bigger the table, the better the machine is, because you may end up having more issues with machining a small part on a big table. Next, consider the overall part size, which includes the fixturing and the clamping solution. Last but not least, look at the tools that you'll be using, because the increased length of the tool that you use would affect the requirement for a longer travel when you are doing machining of the part, at a 90-degree angle. With this, I'll end my presentation for today. Thanks for your patience, and for more information, do visit us at www.5axis.org. It is a microsite specially catered for 5-axis machining. Thanks again for your time, and I'll hand the time back to Tim. Thank you.
Thank you very much for this presentation, Mr. Yip. Now we will move to our second presentation of today, Job Shop Automation Made Simple by Dr. Paul Gray.
Hello, everyone. I'm Paul Gray from Hurco Companies. I'm Vice President of R&D and Product Development. And today I'm here to talk about job shop automation and perhaps shed some light on it to help you see if it may work for you in your shop. So before COVID-19, many shops struggled with how to grow because the labor market was so tight. You could buy more machines, but there was nobody around who you could hire to actually run them. And we hear a lot of stories at the time about missed opportunities just due to the lack of skilled workers. Clearly today we're in a very different environment, but something to consider is that the labor market situation will continue to get more difficult as people retire and the workforce dwindles, and skilled labor will become more difficult to find still. We know I think it's fairly obvious what hiring an employee versus using a robot for machine tending, the differences. And we know that with employees, we can easily reallocate them to different tasks and so on and so forth. With a robot, you do have a fixed cost, and it is more difficult to reallocate to new tasks. So it is something to consider. It is a very valid question, I believe, that should be considered very carefully, is whether automation can hurt employee morale. And from our experience, it's shown that if you involve your team right from the beginning, you get a lot of great things coming from adopting automation. The first is that you're creating opportunities to grow the skills of your employees. And it does show investment in your people. Automation can provide new tools and technology for your employees to do their job more efficiently and allow them and your shop to stay relevant in the fast-paced manufacturing environment that we have today. I think importantly, it allows your operators to focus on the various value-added tasks that they can bring to the table, optimizing your setups and operations. They can really be the manufacturing experts that handle your quality control and so on. And you just allow the robot to do the dirty, boring, and repetitive work of loading the CNC machine tool. It really frees them up to provide more value add to your organization. You know, with all these benefits, we do need to take a step back and consider, you know, what's the holdup here? And, you know, I've got a list here of 7 things, you know, that are not all necessarily true. They can be perceptions of high cost, initial costs, concerns with potential for a lengthy deployment to get a system up and running. Understanding the return on investment can be daunting as well. Does your shop have the talent and skills and knowledge to be able to handle this? There's a perception that robots can be inflexible, and sometimes that is true. But there are new technologies out there that you can take advantage of to provide flexibility for work cells. Parts might be too big or heavy, or, you know, do you do a high mix of a variety of different parts, and that causes you difficulty for automation, or can be difficult to automate. And this leaves many people with, you know, kind of lost in whether they should try to pursue this or not. And that's what the discussion is today. As an example, the USA machine efficiency has been shown to be about 60% utilization. And that's a far cry from 100%. Adding a robot automation system can up that to 80 to 95% utilization. Furthermore, 95% of CNCs in the United States have no form of automation attached to them. So when we see that you can at least get a 20% productivity gain by reducing your idle time, you wonder why, again, the adoption has been so limited. I think a valid question here is, you know, how does your shop compare? What is the utilization rate of your machines? It's something to consider, and as something that may drive you towards looking deeper into automation, the possibilities. Another question that comes up is, you know, can't I just do it myself? And of course, you know, anything is possible if you have the determination and skills and ingenuity to do that. And it does take a little bit more than that. There's a lot to consider: your time, your resources that are available to you, all the research and training you may need to execute this. You know, the equipment sourcing, there are a lot of components to an automation system, designing your system, testing, experimenting with it. There are many things that you need to get in line to make sure you're successful. And of course, we can't all be experts in everything. So consider very carefully what your core competence is in your business and what your focus of your business is. Assess your organization's capabilities and readiness for automation. And just as do-it-yourself projects can go wrong, so can automation too, even if it is contracted through a third party. It's shown through Production Magazine, Machining Magazine, that $100,000 robot investment poorly executed can cost you $86,000 per year. So when automation does go wrong, what are the typical reasons? And we've listed 6 reasons here I think we are most prevalent. The first is not defining your expectations. And I think that goes kind of in line with number 4 in some ways. The scope of the automation system may not be fully understood with everybody. So I think laying out what those expectations are, whether it's a lights out machining or to reduce manual labor loading in and out of the machine, or do you have a production volume that you need to hit? And how much of the machine tending will get automated? I mean, these are very important questions that need to be asked. And again, it helps in this situation, it helps a lot to involve everybody from top to bottom who will be interacting with the automation and system to provide input. Inconsistent project management, that's no stretch of the imagination what can go wrong there. I think, as I pointed out just a second ago there, having your shop floor people involved is critically important here to get buy-in and to make sure that it will be a successful integration and system. Lack of after-sales support, and also assessing your parts and what you're trying to achieve, whether it is reasonable or in good fit for the automation system you are intending. These are all things that need to be considered very carefully. You don't want to be in a situation where everybody's pointing fingers at the end of the day. Why did this thing go wrong? So that is a question. Can it work for me? And the answer is really maybe. And I think it will be helpful to go through the different styles and types of automation, as they all have their own advantages and disadvantages and use cases, applications. So high volume production automation, right? This has been done many, many times for many, many years now. And it's no stretch of the imagination, you know, what needs to happen there. And these are usually fairly big projects and fairly costly projects. When we talk about that type of automation, many people are thinking about 6-axis industrial robots that are caged in. They're very fast, very reliable systems, and with enough volume, you can have a great return on your investment. But they tend to take up a lot of floor space, and they're rather inflexible. They're designed to do the one task that and produce the one part that that they were intended to, and any changes needed in the system, you're likely to have to go back to the system integrator, whoever built the system, and requisition them to make those changes. And one other thing to point out too is since they are big integrated projects, they generally take a long time to get up and running successfully. So the programming costs are generally quite high, as each job is fairly customized. Similarly, for dedicated automation systems, if you really have high production needs for, especially for turn parts, these are extremely fast machines, extremely efficient. Again, you have to have enough volume for a good return on investment with these systems, and they are not really flexible at all. But they are, and their cost is quite high. Now, there are part picking systems where a robot will directly pick up a part from a grid or a plate or a table and load it into a vise in an automated vise in the CNC machine. And then there's pallet systems where a part is mounted to a pallet and the robot arm picks up that pallet and loads it into your machine tool. With pallet handling systems, they're really great for long cycle times because they do take a bit of time to get a part in and out of the machine. And they're really good for heavy parts as well, or even large parts, because they're quite cost effective for those styles of parts. They're generally very easy to program, and you can mount or connect them to multiple CNC machines. And with shelving systems, you can increase the capacity considerably and achieve, very long unintended run times. They can be expensive, and there's a lot of, or there's some hidden costs there that you need to consider. First off are the pallets for the robot system, and next are the fixtures you need for mounting the part to the pallet, whether they're vices or what have you. Those are additional costs to those systems. And another thing to point out is that you're still using, some manual labor here to load those parts onto the pallets, similar to not having a robot and loading parts into the CNC machine. What it gives you is the opportunity to stage a lot of jobs and walk away from it, but you're still doing a lot of work to load those parts onto the pallets. So that's something else to consider with these systems. Talking about robots, we know the 6-axis industrial robots, we've seen them. They're generally caged for safety or have other safety measures like area scanners. They're generally a bit expensive as they require a certified system integrator to program it and integrate it with your CNC machine. They're great for dedicated parts, but it's difficult to do high mix production with them because reprogramming them generally requires that you contact your system integrator. And with the caging, they can be intrusive and a little bit intimidating with their safety systems. Now, you've probably heard of the collaborative robots that are safe to work around humans. They stop on contact. And they're actually very easy to program and ideal for high mix production. And we'll get into that at this point. So for job shop automation, where you have a high mix of parts, cobots such as the Universal Robot are really a great solution. And the reason is their costs are quite reasonable, and they're very flexible for changing over your parts or adding to your processes if you want to add in a parts cleaner or so on and so forth. And they're quick to install, very simple to install. So at the end of the day, you have a very fast return on your investment. You can achieve high capacity for these systems by using drawers or stacking parts. And in a number of cases, these systems can be moved easily from machine to machine. Now, they have their limitations on the weight capacity of the robot and the size of the parts that they can handle. They're generally slower than an industrial 6-axis robot since they need to sense whether they've come in contact with something and stop. And there is a perception that they are lighter duty. So universal robots, collaborative robots, you can read the and look up the payloads. Anything from 5 kilogram to 16 kilogram are typically used for machine tending, and they are designed to work with humans in a collaborative way without the need for additional safety equipment or a safety cell. I've mentioned before, they're very easy to program, and because of that, you don't need a lot of training to be able to get up and running. But I think an important thing here is that machine tending is not just a robot. There are a lot of things that need to be considered before that robot can load parts in and out of your CNC machine. The design and integration itself can be quite daunting and complex. And if you're looking to do it yourself, I think it is worth doing a lot of research as to what is necessary to make that happen. At ProCobots, a subsidiary of Hurco, we provide all of these components in an integrated fashion directly for your Hurco CNC machine. Now, let's go over some of these components. The first is the robot mount. It's got to be sturdy. You can build your own. You can use 80-20. And I caution some of those types of builds as the rigidity and stability of the robot mount is critical for the success of automated machine tending. If things are moving around or you have a lot of compliance in the components, you will have a difficult time achieving a repeatable process, and it will only cause you frustration. It is not a place that you should be cheaping out for your automation system. Grippers or end-of-arm tooling are always required. Pneumatic vacuum grippers are great for picking up on curved surfaces, but of course there's limits to the payload and the accuracy. They're not great for loading into the machine tool, but they can be used very successfully for pulling finished parts out of the CNC machine. There are pneumatic mechanical grippers, or parallel grippers and 3-finger grippers for cylindrical parts. They have very high gripping forces, but keep in mind they have a limited stroke. So if you need to adjust it for a different part, you will mechanically unbolt or change the location of the gripper fingers to be able to do that. The electromechanical grippers are becoming quite popular because they have a large stroke, which makes them very flexible. However, they have a limitation in how much force they can grip, and it can be quite a bit lower than the pneumatic actuated grippers. Gripper finger design. You need to think about the rigidity and strength, how bulky that might be, what materials you should be using, if you need to protect against marring on the part. Very importantly, you need to consider the friction of the gripper finger to the part you're picking up, the material, because with wet parts, they can be slippery. For heavy parts, you might need an encapsulating grip to ensure that you can pick the part up without the part slipping out of the gripper. This is an extremely important thing to think about. Very often we use 3D printed carbon fiber as it's very light and it won't mar up the parts. Also, you can cut costs by using a single gripper. But the problem with a single gripper is the robot needs to enter the machine twice. First to remove the finished part, and second to place the new raw stock material into the vise or chuck of the lathe. So there's 2 times it needs to enter the machine. But it does give you the opportunity to maximize the payload of the robot if you have heavy parts. Another thing to consider is, can you, with your finger design, load the geometry of the stock and pull out the finished part, which could be drastically different in geometry. And that's where dual grippers are very useful, because you can have different fingers for the part that's being, for the stock that's being loaded and the part that's being removed from the CNC machine. It also halves the number of times that basically the robot can enter the machine once to do an exchange with the raw stock
and a finished part and then come out of the machine. So they are more efficient in that way, but of course you are basically having the maximum weight of the part that you can load with the robot. In this study, it shows that a dual gripper setup is nearly twice as fast as a single gripper setup, and I think that should be no surprise. Part presentation is very important to program a robot, to make it easy to program the robot. You want a regular grid of parts. As you can see, these are various different part trays that there are grid plates and so on that you can use to achieve that regular grid. There are vision systems out there. They tend to be less reliable and more costly. If you can use a regular grid of parts, then I think that's really the ideal solution for most situations. Work holding in the machine. There are pneumatic vices that are reasonably low cost. They're really easy to install. You can use your current air system from your CNC machine and tee off of that. But they do have lower clamping forces than hydraulic systems. Vacuum plates, magnetic plates are good for parts that can't be clamped. And of course, hydraulic clamping systems, including lathe chucks, are ideal for very high clamping forces, though you will need an additional hydraulic pump for vices in a mill, and can be quite expensive. There's a lot to consider with work holding. You know, do you need quick exchange jaw systems? Do you need it to be a self-centering versus a fixed jaw vise? How many jaws are you picking up round parts or holding round parts? Then perhaps a 3-jaw system is best. Do you need positive stops built into the system for accurate placement of the workpiece? There's a lot of options in work holding for CNCs. Here's an example of 3 vices in a row to cut 3 sides of the part using the robot to flip the part multiple times. And another example here doing the same thing with a single gripper. So the gripper fingers that were designed for this were moving a raw stock to the machine, and a finished part coming off a rotary table, 5-axis table, coming out of the machine. So quite a complicated gripper design or finger design to achieve that. And here's an example of a dual gripper with a lathe being used to flip the part on a single spindle lathe to be able to cut both sides of it and pull the part out. Very efficient setup, very cost effective. Of course, you're going to need an automatic door of some sort. It's far more reliable to use an auto door than the robot. There are cases where people try to reduce the cost of their system and use the robot to open the door. But the trouble with that is it's just not near as reliable. You'll get false positives with the collaborative robot sensing or triggering collision events and so on. It's really not an ideal situation. We highly recommend having an auto door system. You can load CNC machines from the front door, from the side door. There are a lot of different options for whether it's pneumatic or electric. But in every case, you've got to think about safety, what it means for your employees working in and around the CNC machine. We generally, with the collaborative robots, we like to use these collaborative auto door system. It works kind of like an elevator door, where on contact it detects and it's monitoring the forces, and it backs off if it detects a collision with anything. Very safe to use, very reliable. And quite cost effective for machine tending. Teaching the robot is the next thing. This has been changed dramatically with the advent of collaborative robots. You basically grab the end effector and move it around to the positions you need it to move to. It's quite simple to do. This video will show you how to use the self-leveling system. in conjunction with the universal robot, and it will show you how easy it is to keep the alignment of the gripper to the grid plate and the table of the CNC machine. So here you can see him moving around. All the axes are kind of flopping around. One button, we can align that gripper to the grid plate, and then we can move it in 3 axes, where the gripper's attitude stays level with the table. Makes it really easy to program these systems. Close the gripper, he's got the part ready to teach it where and how to get it inside the CNC machine. The force sensing system on the robots can be used for pushing against positive stops. And I think the idea here is it works similar to the human hand, where you would load a part pressing it against the vise. We can use the robot to do the same thing with the force sensing system built into the robot, the universal robot. This greatly simplifies the programming and loading of parts in the machine, but it also can be used to improve the reliability of the robot loading the parts, because it will sense when it's against those positive stops. It makes your system really reliable, and it is a very important part of machine tending, in our opinion. I won't get too much into the robot interface, but here is a very large stumbling block for those that want to try and do it themselves. There's a lot of different signals and communication that need to happen between the robot and sequencing and with the CNC machine. You have to consider safety systems and, of course, the pneumatic systems as well. And in some cases, some ladder logic needs to be written and installed on the CNC machine to handle the automation system. It can be quite a daunting task and a lot to learn. So that's what we've done with our subsidiary ProCobots. We've made a fully integrated plug-and-play system with the Hurco CNC machines for our customers. And we're providing prepackaged standardized systems. So you can buy a system that meets your production needs. And in this case, I'm showing some of the systems that are with a robot mount built in, which is great for repeatability and makes the systems easy to move between different CNC machines, so they're portable. We also have high capacity feeders like the 6-drawer system, and even a 10-drawer system as well. And the great thing with these are they have a 3-position drawer that allows you to load a drawer or unload a drawer while the CNC and robot are running parts on a different drawer. The first position is the operator load area. The second is where the drawer is staged for the robot to pull and execute parts. And of course, the robot processing station. So this is just a video showing the capabilities, operator loading it, telling the CNC and robot that that drawer is staged. The drawer will be pulled by the robot, and of course the parts will be picked and placed for processing in the CNC machine. Then the robot will close the drawer when it's completed all the parts and move on to the next drawer. The next important thing is, how do you communicate? How do you program the system? We've made it as easy as you can make it. With a Hurco Job Manager, it's a software that uses network communication between the robot and the Hurco control, and it runs right on the Hurco control next to WinMax. And you can program it very easily. By creating and saving jobs. You just select where on the grid plate those parts are, and you can set up the grid plate itself using our wizard and store different grid plates for different jobs if needed, and pull up a job and just queue it to the job queue and tell the system to run. It's really that easy. And we'll run this little video here about showing you how to create a job. You have to select your conversational or NC program, first op, second op, whatever is needed. And then the robot program can be called from the job manager as well. And then simply click where on your grid the parts are. You can save that and save that job and load it anytime you need for when you need to process those parts. And then just queue the job to the job manager and run. I think it's important to talk about what the investment costs generally are. Industrial robots, as you can imagine, can be quite expensive for a system like that. They're very customized. Pallet systems, again, you have to consider the cost of the pallets and the work holding on the pallets. The Pro Cobot systems are, fairly cost-effective for machine tending and are easy to program for high mix scenarios. We have a return on investment calculation webpage on our website that you can go to and see what your break-even point and costs will be for a system. And it also provides a table data for you to help analyze whether this is something that makes sense for your shop. And I like to point out CNC lathes offer a quick win because the work holding in the CNC machine is already there. It's a great place for you to start getting into machine tending or to start your machine tending strategy for your business. And I'll just show you here a quick video of someone loading, starting up a job, telling you the job manager, the Hurco job manager, where those parts are, queuing the job and firing it up. That's all it took to get this system running to cut these parts. Very simple to use. So what we've done with our subsidiary Pro Cobots is we've provided these systems to avoid this problem of integrating various different pieces and to give you a complete automation package that runs right out of the gate with your Hurco CNC machine. And thank you for your time today.
Hello again. Thank you, Dr. Paul, for very interesting and I think very simple presentation that showed how to conduct this in a very easy way. Now, I would like to start our open forum and to answer any questions from the audience that we had. So I'll leave you to it. If you would have any problems or if there would be any questions I can support, I'll be happy to.
Do you want to kick that off, Wyatt, I guess?
Okay, yeah, let me just run through the question and okay, the very first one.
There.
Okay. Can you hear me now? Okay, got it. Okay, so the first question, I'm going to answer two questions about 5-axis. Then I'm going to hand the mic over to Paul on the automation side. So first question, there are a lot of different sizes and styles of 5-axis machine. So how do you know and choose the right one? So this is, I would say this is one of the key questions asked by most buyers when they're selecting their 5-axis machine. So if you recall during my presentation, the last part of my presentation, I talked about the 3 important things, but in general, I would list it down to 3 attributes. First of all, the material type. Depending on what you are cutting, whether it's stainless steel, titanium, plastics, aluminum, or generic materials, that will affect your choice of the spindle and the structure of the machine that you're choosing. It's very similar to choosing a 3-axis machine. The key difference comes in when for 5-axis would be really the part itself. So instead of focusing on the machine attributes, it's really the size of the part. Usually we will take the maximum part that you'll be machining or that you plan to machine on the machine itself to decide on the size of the trunnion and the swing, the available swing for the part itself. So I've actually covered that during my presentation. The other portion that I've not covered would really be the shape of your part. So the shape and the geometry of a part is quite important because that decides on how you're going to clamp, and that's how you're going to design the fixture for your part. One of the classic question posed by most buyers would be, hey, you have a trunnion, you have a swivel head, so which is better? Considering if they have the same travels and the same working envelope. So the shape of the part decides that, because if the part that you're machining involves a lot of undercut, like in the case of impeller itself, then the trunnion table setup would be preferred, because typically it offers a bigger tilting angle compared to a swivel head machine itself. Whereas, let's say if your part is tall, heavy, and big, then a tilting head may be preferred because it allows you to be able to position the part on the table, rotate it, while the spindle will come in from the side to do the machining. So having said that, our recap will be material type, the part size, and last but not least, it will be the shape of the part. So I hope I've answered the question. So let me move on to the next one, also about 5-axis. Okay. Yeah, okay. So how hard is it for my operator to learn programming a 5-axis? They only have 3-axis experience. So if you're talking about a 3+2, meaning multiple site machining, it's as good as learning a 3-axis itself. Basically, if you were to visualize a part itself, the nice part about having a video is that if you're visualizing a part itself, programming a multiple site part, essentially, it's really just tilting and rotating the part. So just imagine holding on the part on your hand itself and rotating it to the plane that you intend to machine. And that can all be done typically with your G68.2 or on a Hurco conversational control or other controllers which offer conversational control. It's about really moving the datum and transforming the plane. So after you have completed plane 1, you transform the plane to plane 2 to continue your machining itself. The real difficulty comes in where we see a more significant learning curve would be the moving from a 3 to a simultaneous 5-axis. Because typically for simultaneous 5-axis, you will require a 5-axis CAM software. And besides having a CAM software itself, tooling, the choice of cutting tools, the choice of the tool holders plays an important part as well, because there's bound to be more interferences involved. You've got to visualize the moving of your part, and that's where the simulation comes in. So the simulation of the part, of your tool path itself, coming from your CAM system itself or on the controller, would help you take care of these issues. So I would say 3+2 is as good as really, putting in an additional day worth of learning how to do the programming. Whereas on simultaneous, it is an ongoing practice. It is an ongoing work in terms of improving your tool path to get the best surface finish and the most efficient way to machine down the part. So I hope I've answered both questions, and let me now hand over to Paul. And I'll post the, the very first one I will choose. Okay, okay, Paul, to you, how much training and programming is needed?
Okay, can you hear me? I hope so. I'm having some troubles here with the PC at this point. Okay.
If you have a trouble,
Give me a second here.
Perhaps you can.
So, if you can hear me, hopefully, how much training is needed to make a cobot work? And that's actually quite simple, especially with the universal robots training, which is really extremely good. And you can basically learn everything you need to know to program the robot within an hour. And if you're using the Hurco Job Manager for machine tending in one of our standardized systems, the training is really minimal because most of the work is already done. You're just teaching a few specific points for the individual parts that you might be automating, and that's it. So you can get up and running very quickly without any prior knowledge at all on robotics whatsoever, very quickly. Yes, I think you're going to have to select those questions for me there, because it's my system's hanging a little bit there. Okay, so how long does it typically take to install a cobot system? When you have the standardized systems like we have, what we provide through Hurco, it can be done in basically 2 or 3 days with training, installation, including the auto door system, all the CNC and robot connections as well. So out the door within a few days. It's very quick. Mm-hmm. What size part lots does it make sense to automate? That's a challenging question because there's no really one size fits all. And I think one really nice way to think about it is to think about, am I trying to automate a shift of work or a half of a shift? Is it something I want to have running to set up and run while I'm not in the shop, or is it something I want to run for the shift while my operator is there and free up my operator to set up and get other jobs running? And I think those are the best ways to think about it. And when you have an answer to what do you want to cover with the robot shift wise, and how you want to the robot to run, whether it's lights out or to assist your operator and programmer, then you can go on to our website and look at the ROI calculator and parse through that and fill out the data and see for yourself if that investment makes sense. What are the typical running and maintenance costs for an automation system? And this is interesting. At least for the cobot systems that we typically sell for the high mix, low to medium volume, the maintenance is really minimal. It's about keeping the system clean, and that's about it. The costs for running those systems for running a cobot are really quite low. For the largest robot, it's typically about a 400 watt power draw. So, I mean, it's less than a microwave to run these things. And they're generally, not running full speed and sitting idle waiting for your CNC to finish. So the power draw on these are really a minimal cost, and don't need to be considered. They don't really consume anything else unless you have a wrist air blast for cleaning off the jaws of a chuck or what have you. But maintenance-wise, there's really nothing that needs to happen other than to inspect and make sure that the system is clean, and that's pretty much it. Mm-hmm. Okay.
Okay, Tim?
Hello. Yes. Thank you very much for answering questions from our audience. I think that it certainly helped to clear some issues as well as answer some doubts or support that move from those companies to that direction. And I'm sure there will be follow-ups through the email conversations afterwards. And now I would like to ask my assistant and colleague here to share his screen so we could process to the lucky draw part. So we have here all the attendees that joined us here today. And now we will draw 4 prizes for the Hurco limited prize. So let's start with the first winner. Mr. Derek Toch, congratulations. We will contact you later for the delivery details. Okay, let's select the second one. Nguyen Dang, congratulations. So some of our Vietnamese audience have been lucky today. Let's see who will be the number 3. Chester Nguyen, congratulations as well. I'm sure the Hurco will follow up with more details, and perhaps maybe can start some discussion about more of the power of 5-axis machining. And let's see who will be our 4th lucky winner. Chong Do Huang. I apologize if I mispronounce it, but congratulations. And would we have any closing remarks from our experts to our audience? Any message for the end?
Well, first of all, I would like to say a big thank you to the participants for today's webinar, and thanks for your patience. And if there are any specific questions that you have after reviewing the presentation, just feel free to write to us. I think we have provided our contact emails and contact details, so let us know if you have any questions. Paul?
Yes, so thank you very much for the closing remark. Here on the screen right now, we can see the contact information where you can contact Hurco for more information about the cobots, about the programs and the support. I would like to thank also all the participants for their question. And I think this will conclude our event today. Please do remember that if you would come up with questions or inquiries later, you can contact Hurco or us as well, and we will pass them those inquiries to our expert speakers. And with that, I would like to finish this event and wish you all a good day and a good business. Thank you very much.